Okay, so in this lesson, we're going to talk about how we measure the spread or the variability of a data set. So to start, two statistics. The first is the range, which is the distance between the minimum and maximum values, which we've been working with already. And then the new one is the standard deviation. So the standard deviation is the typical distance of values in a distribution from the mean. So the standard deviation, also denoted by S of x, is always greater than or equal to 0. Larger values of Sx, so a larger standard deviation, means that there is more spread or more variability within a data set. And again, the standard deviation measures the variation about the mean. So the interpretation of a standard deviation is that whatever the context is typically varies from the mean by whatever the standard deviation is. So we won't be finding the standard deviation by hand. This is the formula here. So it is the square root of what's called the variance. And again, if you do it by hand, it does take a little bit of time. So I'm going to teach you how to use our calculator. And then the range we've already been working with is maximum minus minimum. So again, the range can always be calculated pretty easily. So to find the standard deviation, we're going to be following these 3 steps. Okay. So I have that first example. So I'm going to go ahead to my calculator, show you how this works. So if I follow these steps, I'm going to press second up in my top left corner, and then I'm going to hit list, which is above the stat button. And then I'm going to arrow over to math. And then I want the 7th option where it says STD-DV, so standard deviation.
When you want to travel like a local, but your French is très rusty, download the Google app to help you figure it out. Just tap the camera icon, choose Translate, and experience the city like a local. Get real-time translation in over 100 languages. Download the Google app today.
Okay. And now we can just go ahead and put in our data points separated by the comma, which is right above the 7. So I'm going to type in 14, comma, 14, comma, 12, comma, 19, 27, 26, 31, and then close up the parentheses, and then you can go ahead and hit enter, and that gives you a standard deviation of about 7.66 if you were to round that. And again, I got that just from the calculator. All right, and then to find the range, again, remember the range is the maximum minus the minimum. So the maximum data point here is 31, the minimum is 12, so 31 minus 12 gets me a range of 19. Okay, and we can go ahead and find the standard deviation of this the exact same way on our calculator. So if I go ahead over, so second list above stat, arrow over to math, scroll down to option 7, which is standard deviation, and then type in my data points. So I got 54, 100, 12, 156, 140, 37, and then 91, close my parentheses, and then hit enter. That gives me a standard deviation of about 53.10 if I round that. 10. And then working with the range, again, that's my maximum minus my min. So my maximum is 156. My minimum is 12. So 156 minus 12 gets me 144. So we want to say which data set has greater variability. So again, greater variability means that the standard deviation will be larger. So the second data set has greater variability. And again, my reason why is because my standard deviation is larger. Okay, it's better to use the standard deviation when talking about the greater variability, because the range only looks at 2 of the data points. The standard deviation takes into account every single data point. Okay. So if I go ahead to now my dot plot, so we looked at this in lesson 4, talking about the measures of center. So we found the mean and the median of the goals scored by the 2016 U.S. women's soccer team. So now we're going to find the range and the standard deviation and interpret them in context. All right, so I'm going to start with the range. So the range is not too difficult. Again, maximum minus minimum. So my maximum, looking at my dot plot, is 10. My minimum is 1, so 10 minus 1 is 9. Okay. The interpretation, again, the range is literally the difference between the minimum and maximum values. So if I interpret this, the difference between the minimum and maximum number of goals scored is 9. So that's going to be my interpretation of my range. So now if I want to go and find my standard deviation of this, again, I'm going to go ahead to my calculator, and I do need to put these data points in one by one by one. So this is going to be putting 1 in, what is that, 6 times, putting 2 in 5 times, 3 in 3 times, etc. Okay, so I'm going to go second, list, arrow over to math, option 7 for standard deviation. So I have 1 6 times. I have 2 5 times. I have 3 3 times. I have 4 once. 5 3 times. 9 once. And then 10 once. And then go ahead, close my parentheses and enter that. So I get a standard deviation of about 2.58. Okay, again, and I got that from my calculator. And now we're going to interpret what that means, okay? So again, your interpretation, if you flip back a page, the stem is there. So kind of plugging into that. So we can say the number of goals scored typically varies from the mean by 2.58 goals. By 2.58. Okay, and again, that is what the number means in the context of the scenario. Okay, all right, so next thing we have is the 5-number summary. So first definitions, I have the quartiles of a distribution divide the ordered data set into 4 groups having roughly the same number of values. So to find the quartiles, we arrange again from smallest to largest. And then we're going to find the median. So the median, again, we know splits our data into halves. So the first or lower quartile is the median of the data values that are to the left or less than the median. The third quartile or upper quartile, they mean the same thing, is the median of the upper half of the data. So the lower quartile is denoted as Q1. The upper quartile is denoted as Q3. The interpretations are there. 25% of data points fall below the lower quartile, 75% is above, and then the upper quartile, it flops. 75% is below Q3, 25% falls above. And then my IQR is the distance between the upper and lower quartiles, so that formula to find it is Q3 minus Q1, and that's the range of the middle half of the data, okay? So the 5-number summary, shown here with kind of an example of how it works, are these 5 statistics right here. So the minimum, sometimes referred to as Q0, the lower quartile Q1, the median is Q2, the upper quartile is Q3, and then the max, which might be called sometimes Q4. And what these 5 numbers do is it gives us, again, these quartiles. So it gives us 25% of the data between, again, these 5 numbers. Okay. Describing spread and a distribution. So again, we're looking at the shape. So if I have a distribution that's symmetric, I'm going to describe it using the mean for the center and standard deviation for the spread. If a distribution is skewed, doesn't matter left or right, we use the median as we know for center, but we're now going to be reporting the IQR for the spread. All right, so I have the stem plot shows the distribution of ages of people in a restaurant at opening. So I want to find the 5-number summary of the ages in the restaurant. Okay, so it's easiest to kind of write all of this out. So looking at my stem plot, I have starting 22 and then 28, 33, 36, 42, 47, 50, 52, 55, 58, 63, 63, 67, 69, 74, 78, 83, and 90. Okay, so to start by finding the first number summary, I need to find the median. So I have, if I count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 data points. So I need to split 9 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to split right down the middle. And again, if I look at the median here, since I have that even number, the median is going to be the average of the middle two. So this is going to be 55 plus 58 divided by 2. And that gets me a median of 56.5 divided by 2, which is 56.5. Now I have to find my lower and upper quartiles. So the lower quartile is, again, the median of the lower half of the data. So counting from 22 to 55, there are 9 data points there. So if I find the middle right there is 42. That is going to be my lower quartile Q1. And then if I work with my upper quartile, same kind of thinking. That upper quartile is going to be the median of the upper half of the data. So from 58 to 90, that middle is 69. That is going to be my upper quartile. And then we just know the min and the max from ordering. So the 5-number summary. I have the minimum is 22. I have a lower quartile of 42. I have a median of 56.5. I have an upper quartile of 69, and then I have a maximum of 90. And again, what these 5 numbers do is it gives us a breakdown of 25% of the data. So I know that 25% of the data is between 22 and 42, another 25% between 42 and 56.5, another 25% between 56.5 and 69, and then the final 25% is between 69 and 90. Okay. All right, last one. The dot plot summarizes the distribution of the number of books read in first period over a period of 2 months. So first I want to find the range of the distribution. Again, we know range is max minus min. So my maximum number of books read is 10. My minimum is 0. So 10 minus 0 gets me a range of 10. Next, I want to find and interpret the standard deviation of the distribution. So again, I look at my dot plot. I get all of my data values. So I can go ahead to my calculator. So I'm going to do second stat to get the list. Arrow to math. Option 7 is my standard deviation. I'm just going to go ahead and type all these in. So I have 4 zeros. And then I have 6 ones. I have 3 twos. I have 1 3, I have 2 4s, 1 5, 1 7, 1 8, and 1 10. And I close it and I enter. So I have a standard deviation of about 2.87. Equals 2.87. And again, interpreting that in my STEM. So the context here we're talking about is the number of books. So the number of books read typically varies from the mean. By 2.87. Okay. All right, now I want to find and interpret the IQR of the distribution. So if I want to go ahead and write all of this, data points out first. So I had 4 zeros, 6 1s, 3 2s, a 3, 2 4s, a 5, a 7, 8, 10. So I got to start again. I need to find the median. So I have, if I take a count, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Data points, I'm going to split this by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to split that. And now again, my lower quartile is going to be my median of my lower half of the data. So since my lower half of the data has 10 points, I need to find the middle 2 and take the average. So my middle 2 are going to be these 2 right here, the 1 and the 1, because that leaves 4 on each side. So if I find the average, 1 plus 1 divided by 2, 2 over 2 is 1. And then if I look at my upper half of my data, to get my upper quartile, my middle 2 are the 4s. So it's going to be 4 plus 4 over 2, which is 8 over 2, which gets me an upper quartile of 4. I have Q1 is 1, Q3 is 4. Remember the IQR is the Q3 minus Q1. So my IQR here is going to be 4 minus 1, which gets me a value of 3. And interpreting that, again, the IQR is just the range of the middle half of the data. So the range of the middle half of the data is 3. Okay. Now, which measure of variability would you use to describe the distribution and explain why? So the measure of variability, this is now we're deciding between the standard deviation and IQR. So if I take a look at the shape of this dot plot, that is definitely skewed to the right. And again, in a skewed distribution, we are going to report the IQR. Okay, so I would report the IQR. And again, the reason why is because the distribution of books read is skewed right.